Hello, Raz, and welcome to Computer Science Chats. How are you?
I'm good. How are you?
I'm doing great, thank you. So first, could you please introduce yourself and your educational background?
Yeah, so my name is Raz Besaleli. I am Director of AI Research at SeekAI, which is a company that builds natural language interfaces for data. Um, my educational background is slightly non-traditional. I left high school early and kind of didn't feel like a very well-rounded individual. So I decided to pursue a bachelor's degree in philosophy. I went to St. John's College, which is known for its Great Books program. And everyone there kind of like takes the same classes. Everything is primary to source discussion based. And I'm sorry, I don't, you might hear a dog drinking water. Um, yeah, it's all discussion based, and everyone kind of graduates with the same degree, which is, double major in philosophy and history of mathematics and science. I wrote my bachelor's thesis on Cauchy's residue theorem, which is a topic in complex analysis. It's a method for evaluating definite integrals between imaginary boundaries. After that, I went to pursue my master's of science in computational linguistics at Montclair State University, where I did some research in lexical semantic change detection and detection of like higher level discursive phenomena. Um, Yep. And so yeah, now I'm in semantic parsing. So my research has to do with how we understand natural language utterances as structured representations. So what that kind of looks like is anything ranging from question answering, a lot of cross intersections with natural language understanding, all the way to code generation, which is actually my primary occupation now.
Yeah, thank you so much. So what is it that inspired you to pursue computational science and in particular computational linguistics?
Uh, that's a good question. I'm afraid I have a very mundane answer for you. My mother went to high school with this guy who's now a professor at University of Washington in computational linguistics. I met him when I was like 11 or 12, and he was like, "Yeah, I'm in computational linguistics." And I was like, "Wow, that sounds so cool." I'm 12 and I have no idea what's going on. Um, and I don't know, I kind of just had this very like back burner interest in it. I was more interested in formal linguistics, and that's kind of like what I wanted to go to school for. But I kind of put that to the side during my undergrad studies. And, as I was about to graduate, I was like, what am I going to do with my life? And I decided that, it was either that or, like I don't know, like running off to like a small cabin or in Siberia or something. So yeah, that's kind of how I am right now. And when I started computational linguistics school, the first assignments were like calculate the probability of the sentence like an elephant shot a man in his pajamas, or like build a fake Trump tweet generator. So definitely didn't regret it. Yeah. Does
Yeah, super
answer your
interesting.
question sufficiently?
Yeah, that was great.
Cool.
Could you describe some of the activities that you do through your work?
Yeah, so I lead a relatively small team of researchers. There are three people on my team, and we do a pretty healthy mix of research and development and implementation of machine learning systems. So there's a lot of formal research going on, a lot of like writing papers that are that get submitted to conferences. There's product research, figuring out what we should be using in our products. And then there's, good old software engineering, DevOps, just a bunch of like, infrastructure work that really goes into it. I think what really differentiates natural language processing from a lot of other machine learning um, fields, um, not to trivialize I guess like classical machine learning, but like even doing something as simple as like running an experiment or like training a model is no joke. You know, these models are massive. I don't know if you've heard about, you know, like ChatGPT or GPT-4, but these things have like billions of parameters. So, you know, there's a lot of like distributed computing on GPUs. There's a lot of like using specialized hardware. There's a lot of like crying over CUDA, which is it's like a programming language that's kind of an extension of C that's used for parallel processing on GPUs. Um, yeah, so yeah, it's just a lot of good old programming. I think one of the things is you know one of the things about AI is that it has a lot of misconceptions, and I think that a lot of you know people um, that we interact with that aren't so steeped in it. You know, there's a lot of communication about, you know, managing expectations about like what these systems can and cannot do. A lot of, you know, like telling people like exactly how things work because, you know, people's perceptions of AI are very much like rooted in sci-fi. And I don't know if like you've been on like the hellhole that is LinkedIn and Medium, but like it gets really hyped up and then people make up their own terms for things and then a lot of things get you know lost in translation. So yeah, it's a lot it's I would say actually it's a lot of just managing expectations and telling people exactly what we can do and what we cannot do and you know where we think the field is going and kind of how to adjust our business priorities as such.
Yeah. So what do you like most and what do you find most challenging about these activities?
That was also a good question. I would say what I like most, research is really rewarding, when things go right, I would say. You know, you get these like really awesome serotonin boosts, you know, when your model is well behaved and it doesn't overfit and it converges right when you want it to. I take a lot of joy in, you know, there's a lot of beauty in science, and I think there's a lot to appreciate about like exactly what you're doing. Um, and of course, the people are super fun. I don't if you've met any other you know linguists or people in NLP, you'll find that they're very interesting people, and you get to work with a lot of fun characters, which I really enjoy. Um, I think that what is challenging, again, you know, back to this idea of, you know, helping people manage expectations, is that, you know, AI doesn't really have a good definition. So in a sense, what you're doing is rather like ill-defined. You know, the definition that I like to operate on is that AI doesn't refer to, you know, um, it doesn't refer to like the actual models that people are using. It's very much an artifact of human psychology, right? It's very much like you know people perceiving things to be artificially intelligent. So you know, you get a lot of people you know see a model you know generate texts that looks like it was you know spoken by a human and as humans are very desperate to assign humanity and sentience and agency to literally anything that doesn't have any of those. Um, you know, they generalize. They say, "Oh, well, I've seen, you know, like ChatGPT do this once, therefore I'm going to assume that it just like universally has the skill." But you know, it isn't that. It's a next word predictor. It has no, you know, explicit like reasoning systems beyond, you know, whatever is encoded in the distribution of word forms. A lot of people, especially you know the people who coined the term, Tina Geber and Emily Bender, you know, have likened the model to a stochastic parrot, um, and it's a very good one, but like, or they tend to be very good ones, but like you know, it's difficult to you know get people to understand that these things have limitations, and what they're really doing is they're imitating behavior. They're not actually you know like thinking. So I would say that that gets quite frustrating. Also, the field is you know very slow, but you know it's gotten a lot of hype recently, and I think that there's a lot of like unscientific approaches that are starting to happen. There was this one paper um, that was published by a couple of like very high profile research scientists at like a very big company that claims that GPT-4 was, the nascency of AGI. And it was like weird because I feel like there are many better ways to like say, hey, look, we observed this model to do like all of these things and it was really impressive. Um, than saying that we've reached like achieved like the sparks of artificial general intelligence. Like we haven't. We've just figured out how to like model the distribution of word forms as they are according to human judgment. And it's difficult like reading all of these papers and like all of these claims because they're like, here's XYZ of like why like this NLP model, this language model is AGI. And at the very end there's always like a caveat that's like, oh, by the way, there's no real good definition for AGI or AI for that matter, and we're not going to make one. And also it's okay that my research is unfalsifiable. Like you can call it whatever you want. Like, people were calling like Eliza. Do you know what Eliza is?
No.
Okay, Eliza was a regular expression program that was created in the 1960s to emulate Rogerian psychotherapy, which is basically, repeating, tell me how you feel. Oh, how do you feel about X? And then let's bring this back to like whatever other thing that you described 5 minutes ago. Um, like people thought that that shit was sentient, and so like nothing has changed. And I could make a Python program right now that responds to, are you sentient? I could program it to say yes. I guess we could call that sentient. So I just feel like there's a lot of dilution in like the intellectual kind of like happenings of the community right now, especially that which is a lot more like publicly available. Like we all have like our like small like NLP research communities, but I feel like our public perception is like very much like kind of straddling a very thin line. Yeah. So that, yeah, I would say that that's fairly challenging and frustrating to deal with.
Yeah, that makes a lot of sense. So I read that you're both an NLP research scientist at your company SeekAI, and you're also a graduate research assistant. So how does your experience in industry compare with that in academia?
That's a good question. Um, I think that the two biggest like tangible differences are in like deliverables and kind of like how the workplace is structured. So in industry research, you have like constrained resources, and your research interests are very much informed by product decisions. So even if like you're like engaging in very pure research that like culminates in a research paper, the fact that you're working on it means that it is beneficial to the product. So you have a lot of limitations. You get a lot of resources, which is nice, especially because, like computing for NLP is really expensive. It can take millions of dollars to train a model. So it's interesting, but there is very much this like, overhanging like capitalist undertones to whatever's happening, whereas in academia, you don't get that many resources. You have to apply for grants, you have to like you don't get paid, you get a stipend and tuition remission if you're lucky. And usually your research interests kind of like fall under whatever your PI is doing, your principal investigator, but usually the two are like already commensurate based off of like when you applied. You wouldn't go have an advisor that like makes no sense for you. And yeah, I mean throughout my master's degree, it was very much just like we met once a week for 2 hours to discuss how our research was going, and it was a lot more free form. Whenever there was a conference deadline to submit a paper, you would ask yourself, okay, can I like wrap up whatever I'm doing into like a 5-page short paper and send it off. Whereas in industry, it's kind of a crapshoot as to whether your research is considered private intellectual property or something that can be published. I would say that those are the biggest differences. I have a pretty big appreciation for both of them. I would say that I have a pretty big like love hate relationship with both of them. It's very nuanced, and I as soon as I start getting sick of one, I end up wanting the other, and vice versa. And it's very cyclical.
Yeah, that's great. So how did your educational experience help you in founding SeekAI? And do you have any like advice from what you've learned starting a company?
Yeah, so I will put the caveat that I was not the first founder at this place. I was actually brought on as a second employee. I am considered a co-founder because first of all, I was there so early, and second of all, I architected most of the initial systems at Seek. Also equity. I would say I actually had to grow a lot. Like I had a very strong theoretical background when I started there. But all of like the areas that like I didn't know so much about. So for example, like DevOps, and like productionizing systems, that was kind of a big slap in the face. I was lucky that I was able to do like the two kind of like simultaneously. So there was a lot of synergy between, I hope that's the right word, synergy between what I was doing in academia and what I was doing at my job. I mean, yeah, like the theory's great. Like, it's like nice to know what a confusion matrix is. It's nice to know how to use PyTorch, I guess. I would say that the biggest advantage though is you know, I've learned to like almost never take things at face value and just constantly question my assumptions, which is really nice. I feel like that's like something that was a very like, big lesson to learn. That is, I feel is very important. If something is if something seems obvious, just like constant sanity checks to make sure that like what you're like the assumptions that you're working off are actually like reasonable.
Yeah, that makes a lot of sense. Thank you so much. So I know you touched on this a lot earlier, but how can like the publicization and more, I guess, user-friendly dissemination of NLP models like ChatGPT impact NLP research and like researchers' goals?
Yeah, so again, I think that like the public image of NLP models right now is very unstable. So I think that we're seeing a lot of like negative impact and like the public perception of the field, which is important because like it like this is the stuff that like influences like investors and people who like give grants to like research, and people who prioritize research, like government regulations, and like it's it's difficult because I feel like these models aren't being presented very carefully. And I don't think that they're being presented in a very ethical way. There's a lot to talk about when it comes to like, making sure that like you're not accidentally like confusing an individual into thinking that, something is able to do more than it actually does. If you've heard of like the open like the AI open letter that was published have you heard about it?
Yeah, by like
Yeah.
and
Yeah, and it's like difficult because it's like, people are like, "Oh my God, like we have to like stop training AI models like for 6 months so that we can like catch up just to make sure that like they don't get like, you know, go like Skynet and like kill us all, And I think that most AI researchers or like NLP researchers like specifically would agree that, like the singularity isn't really what we should be worried about. What we should be worried about is, what language models can already do. Language models can produce, content now at an industrial scale. And if they're fine-tuned, it's very easy to fine-tune them to, make harmful content, and misinformation. And if you are able to industrialize propaganda like that, or industrialize like creation of hateful content, that it can destabilize economies, it can destabilize governments, it can do irreparable damage to marginalized and indigenous communities. There's also something to be said about the environmental impacts of these models. Like new ones are popping up left and right, but it takes tens of thousands of metric tons of carbon emissions to train one of these models. And it's like insane that like people are talking about like Terminator as if like that, like some like far off thing is more important than like what they can already do. um so yeah, it feels like people are like prioritizing the wrong things when it talks about when it comes to like talking about like NLP. And um I think that, yeah, those public perceptions, I guess, like harm the community. It encourages pseudoscience. It encourages people to not really have like a well-informed view of what we do. And I think that it poses what could have been like a very easily avoidable moral burden onto those who are working in NLP. Um, because like it's like weird being like someone who's like actively contributing to a field that like you know is capable of so much. Like you almost feel bad for like not going into like AI ethics instead. Does that make sense?
Yeah, that makes a lot of sense. Thank you so much. So, what advice would you have for high school students who would like to get into computational linguistics?
Yeah, so computational linguistics is a weird field primarily because most people who do NLP have advanced degrees, so it's kind of like far off, I would say. Um, the most successful computational computational linguists that I have met have a very balanced um, like background in computer science and linguistics. I think that the background in linguistics is critical so that you don't underestimate the domain of the problem. I think that a lot of people trivialize NLP problems and don't really understand that like language is more complicated than people think it is. And it's not like physical systems, or it's not like deterministic systems. It like it doesn't really have rules. It just has a lot of structure, and that structure is a lot more deep than the words that we say. I think one of the biggest challenges in NLP is that we're very much trying to um, model very deep and latent structures with surface representations. So it's kind of like, let me think of a good analogy. It's like trying to like observe, it's trying to figure out how planets move based off of how they look in the sky. It's a very phenomenal science, which severely hinders it, I think. Um, and I just like think that like having a very like developed appreciation for that is very important. On the other hand, I've also met a lot of computational linguists who like can't code. And obviously you need to be able to do that if you want to go into, if you want to be like a natural language processing engineer or something. Like you have to have like your software engineering chops. So yeah, take that linguistics class, but like also take that computer science class. And then also I would say you know, make sure that your background in math is really strong too. Like you don't need to be taking like, you know, crazy real analysis and like topology and like, you know, whatever, but like make sure that like your calculus is down, make sure that your linear algebra is down. It's all linear algebra. Make sure your probability theory is down, and make sure you understand what you know it means to take a descriptive approach to science rather than a prescriptive one. I would say that those are the biggest things. Um, yeah, also like go to a school that has a lot of money because it literally costs thousands of dollars to fine tune models and run experiments. So, for lack of a better word.
Yeah, thank you so much for all the advice. Where do you think that computing in general or just computational linguistics is going to go in the future?
Um, I think that the architecture that we have right now. Okay, well, first I think it's like important to like exactly, you know, define what computational linguistics is. Computational linguistics is modeling of language. It is not necessarily modeling of, you know, things for which language is a medium. It is literally just saying what words come next. And, you know, how can we make either like symbolic or statistical accounts of, you know, like the distribution of words. Um, so um, I would say that if that is the scope that we're talking about, the future of computational linguistics is largely, you know, up to um, its domain. I think that we're getting a lot of headway in, you know, things like machine translation and like question answering and information retrieval. And I think that, you know, we're already starting to see that we're starting to evolve from like, you know, the information retrieval problem of like given query Q like finds like relevant documents, you know, D. It's become more of like a given query queue, like find like a summary or like get like a well-formed summary of documents, D, which is I think very cool. I think that there's a lot of really exciting prospects for how it can allow us to, you know, easily ingest information. I think that there's a lot of applications for NLP and you know, like language preservation and indigenous languages. There's a lot of really cool headway being made on, you know, NLP for low resource languages. And, you know, whatever we can do to, you know, help, you know, like those kinds of things with the technology that we have, I think is, you know, very important. I think it's made things a lot easier. Um, and I guess it's also bringing up a lot of really interesting like ethical challenges. I think that there's going to be a lot of development in philosophy as a field in the very near future. And you know, as a result in like policy and like intellectual property and law, which I think is all very cool. The future of computing in general, I don't feel very qualified to answer. But I would imagine that things are just going to get faster and bigger because that's how it has gone in the past 50 years. So I can't see how that would be different. I don't think Terminator is going to happen. I don't think like, you know, ChatGPT is going to take over the world or whatever. But yeah, I think at least in academia and in industry there will be some really interesting developments.
Yeah, thank you so much for meeting with me and for being willing to do this interview.
Yeah, my pleasure. Thank you for having me.